in there, chromatograph, that's the catching on it. In chromatograph, we only separate mixtures from our layman's understanding. It's just to separate mixtures. If I mix something and it's called a mixture, then I can really separate the individual components that are present in that mixture. So, okay. So I can separate the individual components that are present in that mixture. And we know from our little knowledge that even ink that we use for writing is a mixture, and we can easily separate the components that are present in that mixture. So even we know that blood is also a mixture. So we can separate the components that are present in there using chromatography as a technique. Yes, so this is what it does, this machine. So this is just an applicator. This is where we put your sample. Whatever sample you have brought to the lab, say for example, you are I know have been informed that you are both investigators, you are on top there, and we are investigating, for example, a fire that has occurred. And maybe you want to prosecute this case further, and they have asked if Mia was the last person to be maybe in the room, or maybe I wasn't there, but you suspect I could have come and maybe could have opened the door and maybe set up fire somewhere. Maybe part of your investigation obviously will start from the door was left locked, and it was someone should have opened it with a key, because there's no visible signs that there was a breakage. So they will get a swab maybe from the handle of the door, so that you match my DNA with the DNA of the swab on the, yeah. And because part of my body is also a mixture, maybe you swab and you bring it to the lab, and we will bring that sample that you have brought. Usually we put it on this instrument, on this panel. I've put a plate here. This is a special plate that is meant for this, and this is where I've put, and using our machine here, it will be able to apply the samples that you have put in here. And this is just a computer. I'll feed in the information according to what I'm trying to investigate. The software is there. It will communicate with this. So apply here, apply here, apply here. Then it will do the application, and then it will take note of what is going on as it is applying. Then after it has applied, then we put it in a certain solvent now that can actually separate those components into thin bands. Once they are done, and then we take to that machine there. This is just a computer, and that is a computer. The other one is a printer. It will help me to print the results. But this machine now is able to, even before I could take there, I would take into that machine, the last one over there, and after I have developed here, it will give me a picture like this, that machine over there. You see how the bands are separated? Yes, in this, yes. At different wavelength, because that's a UV machine. At different wavelength, it will give me different pictures of this. And then lastly, I take it to the machine. Now that is the one that is going to tell me which of these bands that I've separated is which one and which one and which one, according to the software and the input that I've given the software. And then we'll be able to tell, yes, there is this person has got this, and this body's got this. Or maybe on this plate, that separation, if I know that is a DNA for you, I'll just scrub there, put it in another vial, and take to our experts that do now DNA comparison. And then they are able to tell that, no, the DNA of Mr. Lengwe matches the DNA of that sample. So it means that is a person who could have been the last person to have visited the scene of an accident or a scene of a fire. That's one way. So that's the application for our HPTLC. So it's able to separate components. So if you are at the scene, maybe you suspect it could be oils or explosives that have been used in this fire. You are able to tell, you're able to swab certain places. I know you are experts of, I'm not an expert. As we receive samples that you yourselves are brought to the lab, then you are able to swab, what could be the cause of fire. I think we suspect that because of this and this could be an explosive. So let's take swabs at the source of fire. Yeah. And then you swab and then you bring to the lab. But one thing we are always cautious about, us who are working in the lab, is that how did you swab? How did you keep the sample? How did you bring it to the lab? Did you tamper with it? Because it can give you false results. So it is important that you take care of the sample, because